So I work with PBL, Netherlands Environmental Assessment Agency. I work with the Image Integrated Assessment model. So that's a model that studies the interactions between the environment and human systems. And we study scenarios and with the role of forestry in scenarios towards mitigating climate change, trying to solve biodiversity and those kind of topics.
Okay, my name's Tom. And I work at Lund University, and I'm working with a model that's called LPJ-GUESS. And LPJ-GUESS is a model we use to understand how forests work. And we do that to understand questions around how best to manage our forests, for productivity, for carbon uptake, for biodiversity. And we also connect this model into Earth system models so that we can understand the evolution of the world's climate. Forests take up about 1/3 of human emissions of carbon dioxide into the atmosphere. So they're really slowing the rate of climate change. And that's something we really need to understand. And the big problem we have is that there's no observations of that. You can't see this uptake of carbon by forests from space. We have little observations in different parts of the world, and we need something to tie those together. And that thing is models. And the great thing about those models is we can also test, what if we do this? What if we try changing this management? Or what if the climate changes like this? What would happen?
Every year, human activity releases enormous amounts of CO2 into the atmosphere. Forests quietly absorb around 1/3 of that, acting as a giant natural brake on climate change. The problem is, you can't see this happening from space. There are no satellites measuring this uptake directly. That's why models are so critical.
So we'll start with the IAMs, so that's integrated assessment models. That's the group of models that I'm working on. So the image model is also an integrated assessment model, an IAM. And these models are, as I mentioned already, used to study the interactions between the human system and the environment. And so therefore we can explore what will happen under different futures of the society. So what if population grows very fast or not so fast? What happens to the environment? The same for economic effects, for example. And we can also test or explore what may be done to change negative effects on the environment. So for example, what kind of policies can we implement to explore how to limit climate change, for example, or to prevent biodiversity loss. And that's exactly also the role of IAMs in the ForestPaths project.
So Earth system models, they are trying also, a bit like IAMs, to have a kind of integrated view of the world, but they don't include people. But they try and include all of the components of natural systems. So it's the atmosphere, obviously, and the core of that is usually a model just like is used for weather forecasting. But then it's linked up with models that try and explain, okay, this is how vegetation works, this is how the oceans work, how they take up heat, how they take up carbon, this is how ice sheets link into this picture. And so together, all these things interact, and the Earth system models are trying to capture these interactions in a realistic way.
Two kinds of models aim to represent global climate in ForestPaths. Integrated assessment models look at how human decisions on policy and economics shape the natural world. Earth system models focus on nature and track how the atmosphere, oceans, ice and vegetation interact with each other. Neither model includes everything, which is why using both together is important.
We think that forest management is actually really important for understanding how climate develops, but historically it's not been well represented, only in a very, very simplistic way, and the reality is very complex. So what we wanted to understand here is actually how complex do we need to represent a system in order to be able to capture what's important in terms of changing climate, and something very similar for IAMs, right?
And I think both the IAM and ESM perspective are important for one of the key goals of this deliverable of the study that we did is how to achieve these climate targets, and also to advise policymakers for that, because there's big discrepancies in different model studies, but also how countries report on these kind of topics. And that mismatch is, we think, partly due to forest management. So we also wanted to understand that better, so we can give better advice to the policymakers for IPCC and UNFCCC. So that's also part of this.
The chain connecting forests to climate policy is longer than you might think. Decisions made about how to manage a forest, how many trees to thin, when to clear cut, affect how much carbon the forest absorbs. That feeds into what models predict about the future climate. And those predictions are what policymakers rely on when setting targets.
So the image model is by definition more simplistic on the environmental side than an ESM model like LPJ-GUESS, but compared to other integrated assessment models, image has relatively more detail on the forestry sector. So that's why it's useful. We can tweak quite a bit of things on the forest management side and try to study a bit deeper than other integrated assessment models. So therefore it's relatively suitable for the kind of questions that we're asking in ForestPaths and for this study.
LPJ-GUESS is a model for representing forests across large scales, from country to region, like Europe, to the world. And something we've been doing a lot over the course of this project is really developing the details of how we represent forest management, so that we can really represent different actions, like if we clear cut a forest or if we thin it in a certain way. And because we now have that kind of detail of representation, we can look at what the impacts of different approaches would be, and how important it is to actually have that fine detail, which we know is really important if we want to look at productivity or management scenarios in Europe, for instance. But how important is that for the climate system?
So with the image model, we assessed what the effect of forest management is on the carbon sink and changes in CO2 dynamics, which in turn affect these mitigation pathways towards 2 degrees and 1.5 degrees that I mentioned. And what we found is that forest management, in the way it's currently represented in the model, changes, has quite a big effect on the sink and on the CO2 dynamics that we see. And actually it becomes slightly less realistic compared to, or slightly less comparable to historical observations. So we found that the current way of representation in image is not as accurate as we need. So this is clearly an area where we need to improve. And together with the results from the ESM model, we found some ideas how we can improve that.
What would be really nice is if we could look at our results and say, do you know what, we don't need all that detail. We can make this job a little bit simpler. And that's not what we found. You know, as Jonathan said, we need actually quite a lot of detail. Forest management that happened in the past. This is really important for the uptake of carbon that we see now and going into the next decades. And this is something that's still not very well represented in either kind of Earth system models or IAMs, right? So we expected this, and this is something we found, but we also found that it's kind of much smaller scale stuff where you go in and you thin a few trees here and there, which is absolutely pervasive across all of Europe, right? This is really happening everywhere. This is also super important and kind of has similar order of magnitude effects on the carbon uptake that we simulated. And well, that's a bit of a pain, isn't it? Because the other one has quite a bit of data, and this one, the data that exists is actually very scattered. And if you want to do it across the world, there's many places where we don't have good data on that. So that's a bit of a challenge that came out.
This leaves scientists with 2 clear priorities. The first is realistic, given the information and tools available. Building the history of past forest management into ESMs. That data already exists at a global level, and several models are ready to take it in. The harder challenge is small-scale thinning. It happens everywhere across Europe and affects the carbon sink as much as clear-cutting. But it isn't clearly or consistently reported across countries. Fixing that means countries being more transparent about what's happening in their forests, and EAMs incorporating real observations of how much timber is being harvested and why.
The relatively low-hanging fruit is improving the way that we represent the history of forest management, the structure of the forests we have now. We actually have data on this for the whole world. It, of course, varies in quality, but we have consistent data sets, and we can incorporate those into Earth system models. There are several models now that would have the potential to do that. So that's relatively low-hanging. What's more challenging is this fine detail of management, and to do that, we really need to assemble better data sets. And that's partially about people actually going to the effort of bringing together the information on management, but it's also about countries actually reporting more clearly what's actually being done. So there's a big challenge to really represent that well.
I think that also for IAMs, it's similarly very important that we get this better information, either based on satellites or other information, but also actually use that, because we've seen in this deliverable that the carbon sink is not well represented in the integrated assessment model, even though this is very important for how we achieve these climate goals. So including better observations, the area that is actually being used in the past to harvest, to fulfill demand for timber, that's not properly taken into account in the IAM. So better including that, having better data available, but also actually including that in the models in a simplified but decent way, that is really something that we need to do.